Hey there, folks. In this video, we are going to be discussing simplifying rational expressions. The word rational just basically means a ratio, hence the word ratio is in there. A ratio is a comparison of two quantities. We normally think of ratios in terms of fractions. So if you want to think of rational expressions as expressions that are written as fractions, go for it. Now, when we are simplifying, we are essentially reducing. We've all done this with numerical fractions in the past. We've all known and loved it. So to kind of give you an example of what I'm talking about here, if I had 8 over 12 and I wanted to reduce that, we could say that that is 2/3. And the reason why that works is if I were to take 8 and break it apart into its prime factorization, so I break it down into a combination or product of prime numbers. 8 is nothing more than 2 times 2 times 2. All right, that's how you get 8. If I did the same thing with 12, you just make a little factor tree, break it apart into prime values. 12 is nothing more than 2 times 2 times 3. So when we are simplifying and reducing, what we're technically doing is canceling out one-for-one factors of the numerator and the denominator. So a factor from the top can cancel out with a matching factor from the bottom. We're going to do the exact same thing, but now with rational expressions that look kind of scary, but they're really not so bad. One thing I do want to make note of, oh crud, there's another typo. Dang it. One thing I do want to make note of is you have to cancel entire terms, or sorry, entire factors. You cannot cancel individual terms. And I'll explain what I mean once that comes along. All right, so this first one is already factored for us, which is awesome because factoring is the hardest part of these. So what I'm going to look for is anything that can cancel. First, I have a factor of x plus 2. That can cancel with any other x plus 2's down below. I don't see any. The x plus or x minus 3 can cancel out with the x minus 3 down below. I'm canceling that entire factor. That whole parenthesis chunk is just gone. X plus 5 can cancel out with any x plus 5's down below. There are none. So my final answer is whatever was left over, x plus 2 times x plus 5 all over x times x plus 7. That would be our final answer. Over here, our goal is to factor the top, factor the bottom. Because again, we can only cancel entire factors. We cannot cancel individual terms. So a big cardinal sin that some people make is they try to cancel, hey, there's an x squared here, there's an x squared here, let's cancel those out. No. Or some people might think, hey, there's a 10 and a 5, let's make that a 2 over 1. Can't do that. Those are individual terms. They are not complete factors. You have to cancel out an entire parenthesis chunk. All right, so let's get down to factoring. I'm going to use green to factor the top, and I'll use red to factor out the bottom. The top would factor down into, see, numbers that would multiply to 10 add up to 3, positive 5, negative 2. Awesome. The bottom is going to have a GCF of x, and I'm left with x squared plus 6x plus 5. Numbers that multiply to 5 add up to 6. Well, that's just 5 and 1. Both positive. So we have x plus 1. Wrong color. X plus 1 and x plus 5. And I have to remember that I carried that little x along for the ride. So now I'm going to look for entire factors that will cancel. Well, this x plus 5 can cancel out with this x plus 5. One from the top, one from the bottom. And that's all that can cancel. So we take whatever's left over, x minus 2 times x plus 1. Sorry, x minus 2 over x times x plus 1. You'll notice if this is the only factor left in the numerator, you can write the parentheses, but you don't have to. If you want to, go for it. If you don't want to, that's fine too. All right, let's do the same thing over here. Again, some of you might be tempted to cancel out these x squareds. Can't do it. Some of you might be tempted to cancel and reduce 16 over 8 and call that 2 over 1. Big fat no can do. You have to cancel entire factors. All right, so let's take a look at the top. There's no GCF. There's no greatest common factor, so that's just going to break down into a difference of squares pattern, which is x plus 4 and x minus 4. Down below, I'll take out a GCF first of 2. So that 2 is going to be chilling out front of the whole bottom. And I'm left with x squared minus 3x minus 4. Let's see. Numbers I multiply to 4 add up to negative 3. It's either 1 and 4 or 2 and 2. Got to be 1 and 4. So if I say x minus 4 and x plus 1, we'll be good to go. Now we look for things that cancel. X minus 4, x minus 4. Gone. And that's the only thing that's left. So I'm left with an x plus 4. Again, since that's the only factor, you can put parentheses over it or around it. You don't have to. Over 2 times x plus 1. And that would be our final answer. And just as a reiteration, some of you might be tempted to do this, but you cannot. You cannot cancel those x's. Those are individual terms. You cannot cancel and reduce that 4 with that 2. Those are individual terms. That is illegal. Cannot be done. All right, last and final one. The numerator here is almost factored, which is good. But I'm noticing we've got a little GCF up here. So I want to make sure that this is as factored as can possibly be. So I'm going to take out a 2 just from that first term. So 2x plus 6, GCF of 2, I'm left with x plus 3. And then my denominator, oh boy, we got a 12x squared plus 1x minus 1, and there's no GCF to shrink those numbers. The reason why I'm kind of shuddering with 12 is to get a 12, it's either 1 and 12, or maybe it's a 2 and 6, or maybe it's a 3 and 4. There's 3 different combos, which kind of stinks. On the plus side, though, I know the last number here is a 1, and the only way to get a 1 is 1 times 1. So that can help me. So what I need to do is figure out is a 1x and 12x, a 2x and a 6x, 3x and a 4x. Well, if there's a 1 and 12, that would give me a 12 and a 1x. There's no way to combine that to get a 1x. 2x and a 6x wouldn't work. 3x and a 4x could do the trick. So if I did 3x and 4x, I'd want the 3x to be negative. So the 3x is going to be multiplying with this guy over here, that 1. So that would be my factorization. Another nice little thing to pick up on when you're doing these problems, if you factor the numerator, chances are you're probably going to see one of these repeat down in the denominator. So if you're ever stuck, kind of use that as a guide, because these problems are generally built for things to cancel out nicely. All right, so 4x minus 1s will cancel. And I'm left with 2 times the quantity, x plus 3, all over 3x plus 1. And if you want to write that 3x plus 1 in parentheses, you can. But since it's the only factor, you don't have to. And that, my friends, is simplifying rational expressions. As always, if you have any questions, do not hesitate to reach out.